Hello everyone, welcome back. Um, Today I want to discuss one another important topic that is encoding versus encryption versus hashing. What is the difference? Where to use what? Okay. You may hear this terms encoding, encryption, hashing when we do the system design or when we do some applications and all. So what are they, and what are the importance of each of them? Let's first of all let's go ahead and see everything is empty. Okay, suppose I am giving a password where we are using this encoding and all, and we are using HTTP or HTTPS protocol while accessing any of the websites. We used to enter the password while logging into any of the web UI, either in the Gmail or any of the web UI we have access. We'll be entering the username and password. HTTP is not at all secure, that all we know. Then comes to the HTTPS. Okay, in HTTPS how this data is transferred, that is using this TLS, will be encrypted our data using TLS, and then we'll be sending this data. Okay, then comes once we have login details, we have to enter the password. Is this password is going to send as a plain text or an encrypted text or a hashed text through this network system? Okay, let's go ahead and encrypt some password, because um, in any system, suppose if it is Gmail or any of the system we try to log in, we are going to enter the password. That password is not going to send us such. It's not going to send us plain text. What it is doing, suppose if it is a text or username or text, then it will be encrypted before sending through the network. Whereas in case of password, that will be converted into different format. We call it as hashing. And at the end system also, it will be get hashed. Only the hashed value will be saved, and that hash value will be compared with the incoming hashed password. If it is same, the user will be logged in. This is how this process is happening. Let's go ahead and see one by one. I am going to enter one password. Password 123. I have entered password 123. Let's increase the font a little bit. Okay. Now, first discuss about the encoding. Encoding is a reversible process. If you know the encoding technique, we can reverse this back. Okay, this is the encoding. You just copy this value. This is a base encoding used for encoding this password. Just we can use the same thing, and it is decoded. If you have this base encoding and data, we can decode this back. So it is decoded back to password 123. Now come to encryption. Encryption in the sense, um, let's go ahead and write one by one. Where is my ink? Control N. Okay. Okay. So then we'll come to this. Encoding. Why we are using encoding? Suppose my system understand only what mission. Suppose I have a data. I have a data means I have an image. I have an image. My system doesn't understand image. My system doesn't understand image. It may understand only the numbers. It may understand only this numbers. Okay, it may understand only 1 0 1 0 0 1 0 1 1 1 1. It will understand only this binary data. But I have this image data. I need to convert this image into a system readable format, in a system understandable format. Machine understandable format. How we are doing this one? What I will do is I will encode this data. Okay, encode encode is this image to what base64 format. This is just an example. Okay, base64 format. Okay, what I'm doing, I have this image. Image will be converted to base64 format. Base64 format data can be read by the system. This process is called encoding. Okay, always we can reverse this data back in this which format it just use. Using that format we can retrieve the data back. Okay, it is reversible. Yes, it can be reversible. Then next we'll go ahead and see what is encryption. Okay, encryption. Encryption in the sense, encryption means suppose if I am sending some data, secure data through network, I don't want anyone to see this data, but I want the end user to decode this data. Suppose I have some data, okay, I have some data file here, okay, secret data. I want to send this data to an end user who should be able to read this data. Here, what I'm using, I'll be using a password or a key. Using this key, I'll be doing this encryption using this key. Okay, using this key, the end user can decrypt it, decrypt the data in original format. This is called this encryption. Suppose hi hello. In the end, it will be at the rate hash 197 exclamation 259 etc. It will be some encrypted format data. Okay, using this key or public key, the end user can decode it. Decode using public key, or we can or secret. Okay, decode to hi hello. We will get the original text back. This is called this encryption. Encryption, we have different algorithms are there. Okay, encryption. Okay, algorithm uses AES 256. Okay, this is single secret key. Single secret key. Then comes to RSA. RSA, we have one public key, one public key, and second is private key. Public key and private key. Here we have two key, whereas in AES we have only one secret key. These are the two different algorithms available in encrypting the data. This is also reversible. This is also reversible. Okay, let's go ahead and see the other example. See, this is the AES encrypted data. I'm just copying this one. I'm using that one and press enter. It will be decrypted back to password 123. Okay. Suppose if I am giving hello or in Vexa, I am just doing the transfer. It is converted into First, it is converted to base encoding. If you have the encoding technique, use that. It will decode it back to the same content. When it comes to this encryption, suppose if it is encrypted into this value, I can use that encrypted key, and I'll be passing that key here. It will convert back to hello or invalid star. And here, this is hashing technique. Hashing technique, what it will be doing, it cannot be retrieved back. What it will be doing, whether it will check whether the hashes are same or not. Uh, the hashing will happen in our system. When we enter the password, it will hash in our system, and that hash value will be sent to the server. What is this hash value? I'll be transferring this value. We will have this hash value now. It will not be reverted back. In the server side, what it will be doing? In the server side also, it will be doing the same hashing. Same password will be hashed in the server side, and it will check whether these hash are same what is hashed in the server side. So only in that case the password will be authenticated. This is how this hashing is happening. Okay, encoding transform data into another format for safe transport or compatibility. No secret involved. Anyone can resolve it. If they know the encoding technique, they can reverse it back. We can use test tube, base64, and decode it. And using base64, we can do encoding and decoding. It's a reversible, there is no key. Whereas in encryption, scramble the data, so only if the end user have the key or password, then only they'll be able to decode it. Plain text plus AES, or either you can use AES or RC algorithm to do the decoding. It will convert into ciphertext. Those ciphertext will be transferred to the network. Once the end user receives the ciphertext using this key, either it is a secret key by AES or as a public key, he can decode it back. This is reversible, but it requires the key. Whereas hashing, it will create a fixed size fingerprint of data. Okay, so what are the data? It will create a fixed size string. It is a one-way process. We cannot revert it back. What it is doing in the server side also, it will create that similar hash, and it will compare whether these two hashes are same or not. If the two hashes are same, then the authentication will happen. Usually, this hashing will happen in case of what user authentication and this in the any of the system nowadays, they are not going to save the password as plain text. What they're doing, instead of that, whenever we register, those password will be converted into hash values. Only those hash values will be saved in the databases. Whenever we try to log into the system, we'll be generating one same hash value and send it across this network. And at the end, it will compare that hash values whether it is same or not. There is a race condition in that case. Suppose I have one password. Some of the other user is also having same password. What it will happen at that time? Let's go ahead and see. Okay. Um, this condition is two user with same password. Okay. I have user one. One password is password 123. User 99 is also high password. Password 123. In that case, if you are doing this hashing, the hash will be same. Hash will be same. That's the race condition, right? So in that case, what we can do, we can have another principle called salt. Salt. What salt will do before hashing? Okay, password 123 plus it will add some random salt. Okay, random number. This random number is called salt. Salt value will be different for different users. It's a system generated random number. It will be different for different users. User 1, it will be different. User 2, it will be different. User 99, it will be different. And now, this value before hashing is a unique value. is a unique value for each and every user. Now this unique password with salt, okay, password plus salt will be encrypted. Sorry, will be hashed. Will be hashed, and we'll get this hash value. Okay, this hash value will be sent to the end server. Okay, server will have this capability to remove the salt value and then compare the original hash. Original hash will be compared with the um, login system with this DB. User login, there will be a hash plus salt. Salt will be removed while comparing. Then it will compare with the DB hash. And if it is same, the user will be authenticated. Okay. Now the hash value which is coming in from the login session and the hash value which is already saved in the database will be compared, and if both are same, then the user authentication will be successful. This is how this race condition can be eliminated using this hashing mechanism. This is all about this encoding versus encryption versus hashing. These are some security consideration we need to take care while doing the system design and all. Okay, let's go ahead and see this comparison. In encoding, the goal is to change the format completely. Change the format completely means we don't need to do any security kind of thing, or it is not going to encrypt. What it is doing, it is for the to make the system to understand we are changing the format from image to binary format or number or the into the format where system can understand. Whereas in encryption, we are encrypting data using um, AES encryption key, or we can use public key to encrypt, and in the end user, they can use that public key to decrypt it. Hashing, that is, it is maintaining integrity and it is creating a fingerprint. Once it is hashed, it will not be returned back. Once it is hashed, that data cannot be changed back. This is an irreversible process. Reversibility, encoding is reversible, encryption is reversible, hashing is not reversible. Uses a key encoding. No, it is an algorithm we are using, that is base 64 algorithm we can use. We can use the same to do the decoding. Encryption, we are using private key. Either we can use secret key, or if it is RSA, then we can use um, private key and public key for doing the same. Hashing, there is no keys used. It's a altogether different mechanism we're using for the hashing. Output size, as we are doing the encoding, we'll be adding more parameter into that file, so that will be 33% larger than the input. Okay. In encryption, there is a input size plus IV or a little bit. Whereas it's hashing, it's a fixed string size, that is fixed 256 bits for SHA 256. Then common algorithm, we can use base 64 or URL or hex for doing the encoding. For encryption, we can use AES or RSA or CHA-20. These are the common algorithm we are using. Hashing, we can use SHA 256 or MD5 or B. These are the algorithm we can use for hashing. Typical use case, the encoding we are using for JSON payload or email attachment, or this using encoding for attaching the email and all. Encryption, we are using for HTTPS communication and file encryption, and for creating the tokens, we are using this encryption. Whereas in hashing, for password storage, checksums and all. Secret cat form, there is no secret, it's a public one. Who can access this encrypted file? Anyone with the key can access. And hashing, no one will be able to access this hashed information, and this is going to be compared at the end system whether this hashing value is correct or not. This is all about this encoding versus encryption versus hashing. Hope you enjoyed this video. See you in the next one. Have a good day. Bye.